Hey, Matt Mathersum here with Matt Mathersum. Thank you so much for joining us and being a part of this illustrious program today. The critics love it. My wife loves it. We all appreciate you guys being here. Seriously, thank you. Well, today we will be dealing with IBP, and I'm not going to let my 12-year-old adolescent, Matt, take over. Well, he might before the episode's over. But this is going to be integration by parts. If you're new to this, well, this might be a little bit of a shocker, but we will get through it. This is a relatively common example, and it's a simple example. That's why I've chosen to start us off with this today. No sense in starting off with complex problems before we need to get into complexity that problems are. Well, I went down the wrong rabbit hole. All right. Well, anyway, this is integration by parts. And you know with me what we're going to be dealing with. Yes, there's a formula. So let's go ahead and acknowledge that. Get that out of the way. Probably won't like this because it's going to be a little bit ugly, but here goes. All right. So it's going to be U dV equals UV minus our integration of V du. And I will be pointing this out because I know my U's and my V's are really hard to decipher, but anyway, we'll get through that as well. Well, we're going to have to solve for U, du, V, and dV. And if you're not used to U substitution or you're new to it, it's going to almost look like a magic trick. And if you've seen a lot of people do this online, it does seem that way. I'm going to do this on another episode, explain these better. I can't do it today. It'll just deviate too far from the lesson that I'm going to implement here today. So that said, we will be solving for these values of U. Boy, my U's are really bad. And let's just try this all over again. Let me see if I can get this better. All right, let's do U, du, V, and dV. Yes, I know it's a mouthful, isn't it? That's the way it be. All right. Okay, well, starting over here, because we are solving for U dV, let's make sure we understand that. What do we want our U to be? Well, we want it to be this X, and I'm going to show you why here in just a second. So let's going to make the X our U. I'm going to plug in our X value up here for U. This is a U, if you can't tell. Well, next we're solving for the D. Well, no, we're actually solving for du. And the du is just going to be the 1, right? The derivative of X is just 1, and that's going to be our 1 dx. All right, well, what do we want to make dV? Well, not much else we can do except to just make dV the remaining here, and that's what we're going to do. And that'll go down here in our bottom slot of e raised to the x dx. Well, what is my V value? That's pretty much the only thing that's left, isn't it? How can I get that? Well, look, if I integrate this and I integrate this, my D drops away. That's going to give me my value of V, right? V will be equal to my EX. So my V value is e raised to the x. I'm going to erase these integration signs because I don't want us to get confused, but that is how I got there, just so that you know. Okay. All right, moving right along. I think I got all our variables that need to have solutions or values, however you want to phrase it. Well, let's just go ahead and work out what we've got going on here. Again, we're saying that we're solving for the integration of U dV. And I'm just going to bring down our equal signs here. This is our U value, and we said our U is equal to x. So let's put in x. Our V value, we said, is e raised to the x. So that will get multiplied. Now I'm going to do some subtraction from this integral of U. Again, or V, I can't even read my own writing. That's how bad it is. V, we said, is e raised to the x, and it is. And our du value, well, that's 1 dx. All right. Are we still with us? Or am I still with you guys? All right, well, here we go. Let's just bring down the x times e to the x. That stays the same. That hasn't changed. Now I'm going to take the integration, the antiderivative of e to the x, which is just, we haven't done that 5,000 times already. Well, we have. So that's e to the x. And 1, well, that's going to keep us at ex. But I've got this integration here, indefinite integration to be specific. There's no bounds. There's no limits. There's no guardrails. It's all free for all, meaning that we're going to add a constant of integration. That is integration by parts. I hope this has helped you. If you're not used to this, it's not as bad as it looks. Practice this a couple of times and you'll get the hang of it. Well, that's all the time we have for here on this particular episode of Math Madness. I'm your host, Matt Mathersum. I'm going to see you guys really soon.